Hello everybody and welcome to today's lesson on solving rational equations. Our objective for today is we will, drumroll, solve equations containing rational algebraic expressions. Surprise, surprise. In order to solve rational equations, we need to follow the following 5 steps. So really keep those in mind and mark them and read them and remember them. Find the LCD of the entire equation is the first step. Then we need to note the domain restrictions. Then we multiply each term by the LCD. Then we cancel out denominators and we solve. And the last thing we need to do is we need to check for extraneous solutions. Extraneous solutions in this context are solutions that would make any one of the denominators of the original equation turn to 0. So let's move on and start with an example right here. First we said we want to find the least common denominator. The least common denominator of the entire equation. In other words, we're looking and we're taking the denominators of both sides of the equation, and then we get x plus 3 times x minus 2. And now we have to note domain restrictions before we start doing anything else. So our domain is x such that x is not equal to a negative 3, because negative 3 plus 3 is 0, or a positive 2, because 2 minus 2 is also 0. And here are our domain restrictions. And now we can go ahead and multiply each term by the LCD. And what that's going to do is, because the LCD has been constructed using all of the denominators that we could find, it will get rid of all of our denominators. So we're going to multiply x plus 3 times x minus 2 times 2 over x plus 3 is equal to 4 over x minus 2 times x plus 3 times x minus 2. And of course you can think of our LCD as having its own denominator of 1, remembering that we're now multiplying across numerator with numerator and denominator with denominator. But before we even start with the multiplying, let's see what we can get rid of. X plus 3 simplifies against the x plus 3 here, and x minus 2 simplifies against the x minus 2 here. And now I'm going to write x minus 2 times 2 is equal to 4 times x plus 3. I'm going to distribute my 2 to get 2x minus 4 is equal to, and distributing the 4, we get 4x plus 12. And now we have a nice equation that we can solve the same way that we have been solving these since algebra 1. I'm going to eliminate the x term from one side by subtracting by 2x. And I'm also going to move the 12 to the other side by subtracting it, and this time I'm going to do it all in one step. The 2x is cancelled out and so is the 12. So we end up with negative 16 is equal to 2x. Divide both sides by 2, and negative 8 is equal to x. This is our answer. Now let's make sure that this is not an extraneous solution. Negative 8 for x. Can we plug that into our denominators without a problem? Negative 8 plus 3, that's fine. And negative 8 minus 2 is also fine. So yes, check this. This is the solution to this equation. So for our next example, with two terms on one side, we're going to do the same thing, finding our LCD first. But in order to do that, all our denominators must be fully factored. And that's actually not the case here with our denominator x squared minus 3x. We have to factor out an x, and we have and x minus 3 here in parentheses. Now we can go ahead and build our least common denominator. It has to have an x. It has to have an x minus 3. So that covers this part. And then we have another x minus 3, but that's already here with the highest. In other words, the same exponent. And the x is also taken care of already, so this is our least common denominator. Looking for the main restrictions, x such that x is not equal to, now what can x not be equal to? It cannot be equal to 0 because it multiplies everything else and everything would turn to 0. And it can also not be equal to positive 3. And here are our two domain restrictions. And now I'm going to multiply each of the terms by the least common denominator. In order to do that, I rewrote my original equation with a little bit more room for my LCD. And now I can go ahead and simplify. This is the same as that down here in factored form. So that gets simplified. Here we simplify x minus 3 against x minus 3, and on the right of our equation we just get to simplify x against x, and that's all we can simplify. Now rewrite 18 minus 6x is equal to 5 times x minus 3. Let's go ahead and distribute our 5. We get 5x minus 15. And again, we can do this by moving the 6x to the other side. This time we're going to add it. And we're going to add the 15 as well. That means we get 33. 6x are eliminated from here is equal to 11x. And the 15 are also eliminated on this side. 33 is equal to 11x. Divide both sides by 11. 3 is equal to x. Should be our solution. Let's see. If x is 3 and we put it in here, then we get 0. 3 is one of our domain restrictions. That means that we cannot use this solution. This is an extraneous solution. And if we only have an extraneous solution as the only choice, then what happens is we actually end up having no solution at all. So this equation has no solution. Okay, let's move on to the next example. Let's find our LCD, but again, to find our LCD, all denominators must be fully factored. X squared minus 4. By now you have probably immediately recognized this. This is the difference of perfect squares. Yay! This can be factored into x minus 2 times x plus 2. So our LCD needs to have an x minus 2, and there's another one, but they both have the same exponent of 1, so that's the highest exponent. And we have x plus 2. That's our LCD. Now we're going to look for our domain restrictions. X such that x is not equal to positive 2 from this factor and negative 2 from this factor. And again, another positive 2 from here, but we already have that. So we're good to go. Next, multiply each term by the LCD, and again I'm going to rewrite this here so I have more room. And here we go. And now let's simplify what we can. Our x squared minus 4 is all this, so it can be simplified out completely. And on the right, x minus 2 gets simplified against x minus 2. And we are going to write what we have left. 3x plus 6 is equal to x plus 1 times x plus 2. So the right side of the equation needs to be multiplied, needs to be FOILed. Remember FOIL. 3x plus 6 is equal to x squared plus 3x plus 2. And we have a quadratic equation now. And when we want to solve quadratic equations, remember the way we do that is we always set it equal to 0. In other words, we move all terms to one side and have the whole polynomial equal to 0, and then we can go ahead and solve it. So I'm going to subtract 3x from both sides, and I'm also going to subtract 6 from both sides. 3x is gone completely, and so is the 6, and we have 0 here. That's what we wanted. On the right, we have x squared. 3x minus 3x is 0. That is gone, and we have minus 4. Now, x squared minus 4 does look vaguely familiar, doesn't it? We had it as our denominator before. This is our difference of perfect squares, and when we factor this, we get x minus 2 times x plus 2. In other words, we may have two solutions. X could be either positive 2 or negative 2. Those are our two options from the factors that we are left with here. And let's check these with our domain restrictions, with our denominators in the top. What do we see? Positive 2 is not allowed to be a solution because it would turn this factor to 0. Negative 2 is not allowed because it would turn this factor to 0. Now, similarly to the previous problem, in this problem we have both solutions which are extraneous solution, and therefore you already know the answer. These are extraneous solutions, and our problem has no solution. Well, let's move on, and I promise the next problem will have some solutions. On to our next example. First, let's find the LCD. In order to do that, we need all denominators to be fully factored. That's okay on the left side here, but x squared plus x minus 30 is not fully factored. What can we find for numbers that give us a target sum of positive 1 and a target product of negative 30? The answer is the numbers are negative 5 and positive 6. X minus 5, x plus 6 are our factors. So let's find our LCD. Starting from the left, we got x minus 5 here and here, both with an exponent of 1. So check. And we got x plus 6 here, and actually here again. So x plus 6 also with an exponent of 1. So what are our domain restrictions? X such that x cannot be equal to positive 5 from this one, negative 6 from this denominator, and again positive 5 and negative 6, which we already have. So that's all there is. Those are the main restrictions. Let's move on and multiply each term by the LCD. And I'm going to rewrite the problem again in order to have more room. Here we go. Now let's see what we can simplify. X minus 5 can be simplified here against this denominator. X plus 6 can be simplified against x plus 6 here. And on the right side, our entire denominator is the same as these two in factored form, so everything can be simplified. And I'm going to rewrite everything we have. No more fractions, yay. X plus 6 times 5x plus 4 times x minus 5 is equal to 54x plus 5. Let's distribute our parentheses. 5x squared plus 30x plus 4x minus 20 is equal to 54x plus 5. Combining our like terms, we get 5x squared plus 34x minus 20 is equal to 54x plus 5. Now, since we have a quadratic equation, in order to solve it, we want to set it equal to 0. In other words, we have to move the 54x and the 5 to the other side by subtracting 54x and 5. So we get 5x squared minus 20x minus 25 is equal to 0. Now, before we start factoring this, let's remember that if there's a greatest common factor, we have to take it out. And indeed there is. 5 is the greatest common factor, and we are left with x squared minus 4x minus 5 is equal to 0. Now, what we have in parentheses, we can factor way more easily. Target sum of negative 4 and target product of negative 5 give us the two factors x minus 5 times x plus 1 is equal to 0. In other words, our solutions presumably are positive 5 and negative 1. Now let's see and check with our domain restrictions. And what are domain restrictions? What can x not be? X cannot be positive 5 and negative 6. So positive 5 cannot be a solution. Negative 1 is fine. So our only solution is x is equal to negative 1. Well done so far, and now go ahead and watch the second part of this tutorial.